Indirect evidence for the existence of atoms. Laws of chemical combination. Question 15. The natural abundance and isotopic masses of the element silicon relative to carbon-12 are, for the isotope of silicon that is molecular weight 28, we have a percent abundance in the world of 92.21%. The isotopic mass of this isotope is 27.97693. The isotope of silicon with molecular weight 29 has a percent abundance of 4.70 and an isotopic mass of 28.97649. And the isotope of silicon with molecular weight 30 has a percent abundance of 3.09 and an isotopic mass of 29.97376. And the question asks us to calculate the atomic mass of naturally occurring silicon. So what we can immediately see is that these three isotopes of silicon are the only forms of silicon that exist, for all intents and purposes, for this question. In the world, there are just these three types of silicon. Silicon-28 accounts for 92.21% of all silicon on the Earth. So the majority of silicon that is naturally occurring is silicon-28, with an exact mass of 27.97693. 29 and 30, these account for about 7.8% of all the silicon present on the Earth. And these are their exact isotopic masses. So because we know the abundance of each form of silicon and their exact isotopic masses, we can calculate the atomic mass of naturally occurring silicon, because it is essentially a weighted average of all of the forms of silicon that occur on the Earth. So, let's get started. We'll use the percent abundance as a weight in our calculation of the atomic mass of naturally occurring silicon. So we can think of this process as weighing the more frequently occurring isotopes more heavily. So silicon-28 occurs much more often than the other forms, so its weight will account for more of the atomic mass of the naturally occurring. So because we have three isotopes, we'll have three elements to add together to get our atomic mass, which is a weighted average of all the isotopes in the world. So let's first write a general equation. So the atomic mass for any element is equal to a weight times a mass plus another weight times another mass plus another weight times another mass. And we could go on for the number of isotopes for a given element. But because this is silicon, we know that we will have three weights and three masses. The weights are the abundances, the masses are the exact isotopic masses. So the atomic mass for silicon is equal to 0.9221, that's the weight of isotope silicon-28, times its mass, 27.97693, plus 0.0470 times 28.97649, plus 0.0309 times 29.97376. So what we find, if we perform this calculation, is that the atomic mass of silicon is equal to 28.086. So when you look at a periodic table, this is the atomic mass that should appear. It's the weighted average of all the isotopes that occur, the average weight of all the silicon atoms that exist in nature. Because that's what atomic mass is, an average weight of all the atoms of a given element in the world. And this answer should make sense around 28, because we see that the most abundant isotope, silicon-28, has a mass a little below 28, and the heavier two isotopes have a rather small abundance, so we get an average mass, or an atomic mass,
of around 28.086.